there are 3 transition series in the periodic table: first, second and third transition series. In the series of lecture, I am going to introduce to you the chemistry of these 3 transition series. To begin with, let us start learning about the first row transition series element. In this lecture, I am planning to introduce to you the subject. We are also going to learn the importance of transition element. All the transition elements are distributed widely in the nature, as well as they are part of our body. Many of the transition elements are very essential as far as the biochemical reactions within the body is concerned, and therefore, we will understand why we have to study the chemistry of transition element. And in the end of the lecture, I will give you the perfect definition of transition element, and we will also see some electronic configuration of the first row element of the transition series. So, let us now understand where this transition element is distributed in the nature. You have seen the rocks and minerals. In rocks and minerals, transition elements are widely distributed. You have seen the gemstone. Gemstones are of course very precise, but at the same time they are colored, and this color of this gemstone is due to presence of transition elements into it. The rubies are red in color due to presence of chromium into it. Sapphires are blue due to presence of iron and titanium, and the color of the emeralds is due to substitution of the beryllium in its structure by the chromium. This slide show you the different gemstones, and you will see that the beautiful color of the gemstone, which are the parts of some of the ornaments also, are due to the presence of transition element. So, whenever now you see this gemstone, please do not forget to recall the transition elements. Now, as I was talking about, the color of this gemstone is due to presence of the transition metal ion into it. So, in particularly in ruby, in aluminum plus 3 in the structure of the rubies is being replaced by chromium ion to give the red color to these rubies. Similarly, in the sapphires or in the emeralds, some of the aluminum ion in its structure is being replaced by the chromium ion to give this beautiful green color. Although in both this gemstone, chromium ion is present, but the structure or the geometry of the chromium ion is different to give the red color to one and the green color to the other. Apart from the minerals and the crystals, these transition metal ion are a part of biological system as well. Many of the biomolecule found into the nature as well as into the human body do contains the transition metal ion. First among this is vitamin B12, which contains cobalt. Also, some of the respiratory molecules like hemoglobin, myoglobin and cytochrome C contains iron into its structure. You are aware about the enzymes. Enzymes are the biocatalyst. Many of our biological reactions within the body do not occur at all without the presence of enzyme. Enzymes are very specific in their action also. This enzyme also contains traces of the metal ion. We will see about the metalloenzyme and metalloprotein in one of the lecture in this series. The metalloprotein also contains a key life processes such as respiration and also protects cell against the diseases. One of such protein is hemoglobin, you are aware, which do the function of transporting the oxygen throughout the living system. The function of the hemoglobin will be affected if there is no transition metal ion into it. Particularly, it contains iron in +2 oxidation state. If there is no iron, then the function of the hemoglobin would hamper. Vitamin B12, which prevents pernicious anemia, also contains cobalt atom and gives a red color to it. This was the structure of the hemoglobin, particularly as you can see the iron is octahedrally surrounded by the 6 ligand molecule. In fact, there are 5 nitrogen is attached to the iron and the 6th position is free, where any atom or molecule can attach. Particularly when oxygen is attached, it is called as oxyhemoglobin, and when this oxyhemoglobin will deliver the oxygen to the cells and tissues, then it will be replaced by carbon dioxide, and during exhaust we can exhale the carbon dioxide, and therefore, there is a two-way function of a hemoglobin, that is to say it will deliver the oxygen and carbon dioxide will come out of the body. So, in the structure of this hemoglobin, as I was talking, the transition element, that is iron, is very important and it is a heart of this molecule. Some of the porphyrin molecule also plays a role in the biological system, in which we have cytochrome C and some other which also contains the transition element in this structure. Now, let us see what are the role of a transition element in the biological system. We have a vanadium, which also having a part of some protein molecule, and it is its function is redox couple in the fat metabolism. Chromium also a part of glucose tolerant factor, and glucose utilization in the body is governed by the chromium. Iron, as I just now told, is a part of a hemoglobin and myoglobin, and it functions the oxygen transport and cell respiratory system is governed by these particular proteins. Apart from the iron, cobalt, copper and zinc are also equally important as far as the biological functions are concerned. Copper is a part of a protein called ceruloplasmin, which do the hemoglobin synthesis within the body. So, after understanding this, we will come to know that the transition elements are not only important as far as the distribution into the nature is concerned, but they are very equally biological important, and therefore, we have to understand the chemistry of the transition element. Transition element are, as I told, a part of a periodic table in which they are a part of a D block, and therefore, the other name for the transition element is a D block element. So, now we, as I told you, the transition elements are very important, and therefore, we have to study the chemistry of transition element. In the periodic table, they are lying in the D block, and therefore, they are often called as D block element. They are the part of a periodic table, and from group 3 to group 12 is the position within the periodic table. In these elements, the D electron or the electron will be added into the D subcell, which is a penultimate cell for these elements. The D block element, as I told, is lying between S and P block element, and therefore, sometimes the word transition element or transition metals is used for this metal ion, because when you have to pass from S to P, you have to pass via D. But the IUPAC definition of the transition element is not this, it is something different. It is not just the location of these element within the periodic table gives the name transition element to this, but as I said, according to IUPAC definition, it require to have at least one D electron into its electronic configuration. So, this is how in a periodic table the position or the location of the transition series element or D block element is lying, and as I was talking, they are located between S and P block element. This picture gives you the feel of the native metal ion, that is, in the laboratory you might have seen the various compound of transition element, but you might not have seen the native state of transition element. So, this figure represents the picture of the transition first order transition metals in their native states. So, now as I told, the d block element are all metallic element, and therefore, sometimes the word transition metals is betterly used for these elements rather than transition elements. Why they are metal? Because their properties are typically metallic property. All of you are aware that metal are good conductor of heat and electricity. So, all this d block element or transition element are good conductor of heat and electricity. They are very hard and strong. In fact, the bicycle made up of titanium will be very hard and very durable. Apart from the titanium, there are other transition metal are also equally hard and strong. Transition element are malleable and ductile, that is to say, you can stretch them into the wire and you can form a seat out of the transition element. Some of these are having so good at malleable and ductility that they are useful in the formation of an ornaments. Moreover, they are lustrous, very shiny, and the melting and boiling point of the transition elements are very high. Exception is only mercury, which is low melting and occurred liquid at a room temperature. They are extremely useful as far as the construction material is concerned because of the strong and unreactive nature, and therefore, the transition elements are, as I told, are also called as transition metals. Now, again we have to come back to the discussion that why name transition. As I talked earlier, that not just because we are transiting from S to P via D, the name transition is given, but according to IUPAC, the transition elements are elements that contains an incomplete D subcell, that is from D1 to D9, and at least one of the oxidation state, it do contains one electron at least in their D subcell. Then and only they will qualify as a transition element or transition metal. Looking to this definition, if we see the structure of scandium and zinc, then we will find that in this scandium in +3 oxidation state, there is no electron present into d orbital, as well as in zinc in +2 oxidation state contains fully filled d orbital and do not contain any unpaired electron into d subcell, and therefore, this two element is excluded from the definition of a transition element. However, there are various compounds of a zinc as well as scandium in which these elements have at least one electron in their electronic configuration, and therefore, in order to include this element, we have to expand the definition of transition element. So, on the basis of this definition, as I told, scandium and zinc do not count as a transition metal or a transition element, even though they are a member of a d block family, and this is because their electronic configuration. So, now after understanding this, let us now understand that why copper is considered as a transition element. Particularly, copper has a 2 oxidation state, +2 and +1. In other words, we have a cuprous and cupric. In cuprous, that is copper +1, the electronic configuration will be something like this, 3d10 4s1, and therefore, it also contains all the d orbital fully filled with the electron, and therefore, there is no unpaired electron present into the d orbital, and therefore, the copper +1 is not considered as a transition element. However, as I said, copper have a 2 oxidation state. In +2 oxidation state, copper will have 3d9 electronic configuration, which contains one unpaired electron, and therefore, copper in +2 oxidation state is called transition element or transition metal, and therefore, copper is of course a transition element, while scandium and zinc, due to unavailability of the d electron, is out of the transition series or transition element. However, their properties and the properties of some of the compounds of these elements are very similar to the transition metals, and therefore, they study together with the transition series element. As I said, copper plus 1 is non-transition, while copper plus 2 is a transitional element. So, after seeing the definition of a transition element and understanding that which element qualifies as a transition element and which elements do not qualify, let us now try to compare the properties of this transition series element with the already studied S block element. Particularly when we are talking about some of the physical property, then we will find that some of the properties of the S block element is quite different than those of D block element. Particularly the melting point, boiling point, density and hardness. If you compare these physical properties of transition element, all these will be very high compared to those of S block element. It reminds me here that the S block element are so soft that some of the metal, alkali metal can cut it with knife. The example is a sodium. However, the all D block element are very hard compared to the soft alkali metal. Their melting point and boiling point are also sometimes more than few hundred degrees centigrade. Apart from this, the another striking feature of the transition element is their occurrence into variable oxidation state. Some of the transition element can occur in +2 to +7 oxidation state, which is rarely found in case of a S block element. S block element can have either +1 or +2 oxidation state, very common. Another striking feature or important property of the transition element is lying in their ability to form colored compound. In other words, the chemistry of transition element is colorful chemistry, while the chemistry of the S block or P block element is colorless chemistry or black and white chemistry. And therefore, if we like the color, we have to learn the chemistry of transition element. Moreover, the transition element or transition metal forms a large number of complexes. The complexes or complex compound of the S block element are known, but they are very few in example. Some of the transition metal ion are assisting the catalytical processes, whether it is homogeneous, heterogeneous or biocatalyst or enzymes, the metal are part of it. This is generally not found with the S block element. So, now I am going to give you one task. In this task, what you have to do, I have mixed some of the properties of the S block element with the D block element. You have to identify that which of these property are for transition element and which property is for non-transition or S block element. Say for example, first one is say colored compound. Just now I said that transition element do form colored compound. Soft and brittle. This is of course not a property of a transition element, because transition elements are not soft, they are very hard, they are not brittle. And therefore, out of this property you have to select, drop and drag the property into this. If you do not know, let us find the answer. So, these are the properties of a transition element and these are the property of an S block or alkali and alkaline earth metal. That is to say, transition elements or transition metals are having very high density, they are hard and tough, they are having high boiling point and melting point, they form colored compound, they are slowly react with water as well as air, and with the acid also they react very slowly to liberate the hydrogen. And therefore, these are the property of transition element, and those which are remaining are the properties of a non-transition element or S block element. Now, let us see the electronic configuration of a transition element. While learning the electronic configuration, we have to follow the Aufbau principle, Pauli's exclusive principle and Hund's rule. Now, in the transition element, we have a two cell, namely 3D and 4s. When I am talking about the first transition series, we have a 3D and 4s. In general, there is a ND and N plus 1 S cell in all the three transition series element. The S cell is a valence cell, while the D cell is second last cell, that is penultimate cell. If you consider the energy wise, valence cell 4s is outermost cell and must be higher in energy, and 3D must be lower in energy. But when we see that there is a very less difference in the energy between 4s subcell and 3D subcell, and therefore, what happened that 4s subcell will occupy with the electron first, and then electron will start occupying into the 3D cell or 3D subcell. And therefore, what happened is in transition element we have 3D 1, 2, 3 up to 3D 9. So, this diagram explains that how the energy of the 4s subcell is lying lowest compared to the 3D, and therefore, the valence cell 4s is occupying with the electron first, and then electron is entering into the penultimate 3D cell. Similarly, while removing the electron also, the electron will be first removed from the 4s subcell and then from the 3D subcell. So, if I give you the task to write the electronic configuration of say first transition element scandium or the last transition element say zinc, then it will be something like this. In the scandium, we will have 3D1 4s2, and in the zinc we will have 3D10 4s2. Once you know the electronic configuration of a first and last element, it will be very easy for you to write the electronic configuration for rest of the element. So, this particular picture gives you the electronic configuration of all first row transition elements starting from 21 to 30. First is a scandium and last one is a zinc. In between, you have to go and add 1 electron into the d orbital, going to give you the electronic configuration 3D1, 3D2, 3D3 etc. But stop, there is a anomaly. Anomaly is at chromium and it is at copper. If you look at the structure electronic configuration of this element, then you will find that chromium should have 3D 4 4s2. Instead, it is having 3D 5 4s1, and copper should have 3D 9 4s2. Instead, it is having 3D 10 4s1. So, why this anomaly? Anyway, we will going to answer this anomaly slightly later, but before answering to this anomaly in the conventional way, how you will write the d electron, that is also shown in this figure. As I was talking about chromium and copper, the anomalies in the electronic configuration can be answered very easily with the fact that any orbital which is if exactly half filled or exactly full filled will be more stable or will be extra stable, and therefore, the electronic configuration of chromium will be this and that of copper will be this rather than these two. These are some of the general properties of the first row transition element. Particularly, they are also forming ion, cation in +2 and +3 oxidation state. These are the values for their electronic negativity, ionization energy and atomic as well as ionic radius. All this we are going to learn in the next series of lecture. So, in this lecture I have introduced to the transition element to you. We have also seen the importance of transition elements in the nature as well as in the biological system, and we have also seen the IUPAC definition of transition element and why they are called as transition metal, why particularly copper and zinc and scandium are considered as a transition element or not considered as a transition element. that also we have tried to answer, and in the end I have given you the electronic configuration of the first row transition element.